Let's do another video. So in this video, I'll be solving a previous year KTU question paper on MOS. This question is from module 5. In module 5, this is from stress transformation portion. Okay. So the question was asked in 2018 April and it was asked for 18 marks. So question looks like this. Stresses at a point in a strained material are 50 MPa tensile and 20 MPa tensile on two mutually perpendicular planes along with shear stress of 15 MPa. Find the principal stresses and planes on which they act. Also find the maximum shear stress in the plane. Okay, so what all we have to find? We have to find principal stresses. We have to find principal stresses. We have to find planes. We have to find principal planes. Principal planes we have to find. We have to find maximum shear stress. Maximum shear stress. Also, we have to find plane of maximum shear stress or planes of maximum shear stress. Right. So first step is basically you have to draw the stress block. So let me draw the stress block here. So stress block is a representation of two-dimensional. So this is a two-dimensional stress block. We are representing the state of stress in a point using stress block. So what we have is we have 50 MPa tensile in one direction and 20 MPa tensile in other direction. So we have, let's say this is my x direction, 50 MPa, and we have tensile of 20 MPa. Okay. Then we have a shear stress of 15 MPa. So let's draw a shear stress here. So any side you just draw the shear stress. So once you draw shear stress in this side, you have to automatically draw shear stress in this side for vertical equilibrium. Now if you see, if we have these two shear stresses, this block will try to rotate in anti-clockwise direction. So to prevent that, we should have a equal and opposite shear stress in this direction. So all these shear stress values are 15 MPa. Okay. So whatever shear stress I have drawn in these planes, these are called complementary shear stress. Okay, this is additional information. Now I will assume this to be x direction, this to be y direction. Now what is given to us is we have sigma x. Stress in x direction is plus 50 MPa, plus because it is tensile. Tensile stresses are assumed to be positive. Sigma y is plus 20 MPa and tau xy is 15 MPa. So tau is also given as plus, so we don't have to worry about shear stress sign and here. Now we want to find principal stresses, principal plane, maximum shear stress, planes of maximum shear stress. Okay, so this is completely very straightforward problem. We want to know what is the formula for principal stress. The formula for principal stress is given as sigma 1 2 equal to sigma x plus sigma y by 2 plus minus under root sigma x minus sigma y by 2 whole square plus tau xy whole square. Right. Now this term we call as sigma average of the average stress, and this term is nothing but radius of the Mohs circle. We call this as R. Okay. So if you split it into two parts, it is easy for our calculation. So sigma average equal to sigma x plus sigma y by 2, that is 50 plus 20 by 2, that is 70 by 2, that is 35. Okay, and R equal to sigma x minus sigma y by 2, that means 50 minus 20 by 2 square plus 15 square. So this comes out to be 15 root 5. 15 root 5 MPa. Okay. So now we can find the principal stresses. Sigma 1 equal to 35 plus 15 root 5 which is equal to 68.54. You can check the calculation. And we have sigma 2 equal to 35 minus 15 root 5, which is equal to 1.45. 1.458 MPa. So these are my principal stresses. So we have found that. Okay. Now what we will do, we will find the plane, principal plane. So for principal plane, we have to use the formula tan 2 theta p is tau x y upon sigma x minus sigma y by 2. So this is basically tan of this by this. Okay. So whatever term is there inside the under root, tan of shear by tan of this value, this. So this comes out to be 15 upon sigma x minus sigma y by 2. It is 15 minus 20, 30 by 2 is 15. So this gives me 2 theta p equal to tan inverse of 1. Tan inverse of 1 is 45 degree. So 2 theta p equal to 45 degree. So theta p equal to 22.5 degree. Okay. So you can also find one more plane. Second plane also we can find. So that is by adding 90 degree to this, adding or subtracting 90 degrees. So 22.5 plus 90 degree. Okay. So this is another 112.5 degree. So this is also another plane. Okay. So I'll explain this plane once I draw this. So this part is over. Now what we have to do is we have to find the maximum shear stress. So let's find the maximum shear stress. So we have already found the maximum shear stress. We just have to identify that. We know that tau max is nothing but plus minus r. Okay, it is the value of this. This is the maximum shear stress. So that is equal to plus minus 15 root 5. 15 root 5. So that is equal to that comes out to be 33.54 plus minus 33.54. So this is the maximum shear stress. And plane of maximum shear stress, that is also simple to find. Theta s is given as theta p plus minus 45 degree. So this is 22.5 plus 45, which comes out to be 67.5 degree, or 22.5 minus 45 to minus 22.5 degree. Okay. So these are the planes. We have found planes of maximum shear stress. Now we will draw the block. It is better if we can we can finally draw the stress block corresponding to both maximum shear stress and maximum principal stresses. So let's try to do that. So this is not required. If you do that, it is good, but it is not actually required. Okay. So let's try to do that. So principal plane, as I told you, this is the origin stress block. Now I have to rotate this by 22 degree, 22.5 degree. So some approximate rotation I am doing. So this rotation is 22.5 degree. degree. Okay. So I'll draw a little more realistic. 22. So this is this orientation is the orientation for maximum stresses, maximum principal. This is nothing orientation for the principal stresses. Okay. So I will remove the shear because in the principal plane there will be no shear. So we have value 68.54 MPa and 1.458 MPa. Okay. So these are the this is the orientation 22.5 degree. There is no stresses here, shear stresses here, because this is the principal planes. So principal plane, the orientation of principal plane is what we have found is 22.5 degree. So orientation of this plane is 24.5 degree. Orientation of this plane is 112.5 degree. Okay, so this plane orientation is from this original axis, it is 112.5 degree. So the orientation of this plane is denoted by the normal of the plane. So its normal and the original x-axis, the angle is 112.5. So that is why we are getting the second angle. The first angle for this plane, it is 22.5. So 22.5 plus 90 will give me orientation of this angle, this plane. This plane and this plane, it is basically parallel plane. So they both have same orientation. This plane and this plane also have same orientation. Okay. So that is why only two angles you have to find. You can also find 22.5 degree minus 90, then you will get this plane. Okay, so minus plus, it is basically just the orientation, but if you see these two planes will be parallel. So this is principal plane, planes and stresses. Okay, now if you want to find shear stress, you have to rotate by instead of 22.5, you have to rotate by 67.5 degree. Then you will get the plane of maximum shear stress. In that plane, there will be some principal stresses that you have to do some calculation to find that. So that it is not asked, so I am not putting time into that. We have already done a previous problem explaining that type of question. So that also you can check in the channel. So that's all. I hope it is clear. So if you do this, I have taken some time because I am explaining and doing it, but practically it's just it will take two formulas that you have to remember, 1, 2 and 3. These are 3 formulas that you have to remember. If you can remember these 3 formulas, you can solve it. Okay, so it is very important that you know the formulas. Recollection of formulas are very important to score marks. Understanding of formulas is very important to properly identify the problem and what is asked. So that's all. We will meet again with another problem in the next video. Thank you.